Hello everyone. In this video, I'm gonna talk about 8051 assembly language instructions. So first of all, let me tell you that 8051 is the microcontroller where we have four ports: P0, P1, P2, P3, and we can connect them using wires into special devices like, for example, push button to make some action. Uh, Resistors, and also we can connect them into LEDs to turn off and turn on them. And also we can use, for example, 8 by 8 dot matrix to display characters or string, right? So, but right now I just want to explain you the basics, I mean the basic instructions, because that's the background of all these things on the hardware. All right, so here we have move instruction and A register and also B registers, as you can see below. So, in the 8051, for example, there are registers like A, B, R0, R1, R2 till R7. But the main one is A because it's called accumulator and we use it almost everywhere. That's the main operand. We use it for the move, add, and or XOR and increment, decrement, and other instructions. But comparing with B, B is usually used only in the multiplication and division instructions. So now let's commence to the task. So here we have two, let's say, operands. This value is going to the accumulator. In other words, that's the source and we are loading that source into the destination. So right now, A is hashtag 3A hexadecimal. And that's the value of A right now. And we want to find the accumulator's value in this instruction. So add, it means addition. But how we can do addition just only with two operands? Um, Visibly, it's kind of impossible, but you have to know how it works. In this case, add a hashtag C2 hexadecimal means A is equal to A plus C2 hexadecimal. A right now is 3A, so 3A plus C2 is equal to, so A was 10, so 10 plus 2 is 12. 12 is C, and 3 plus C, C is 12, right? So 3 plus 12 is 15, which is F. So we got our value. We can write in this form, or we can write, let's say, A is equal to 0x FC. If you remember from the MIPS assembly language, we used to write 0x as the representation of the hexadecimal number. So let's say that it's our answer. We can also accept this answer too. Next, we load new value into the accumulator. But as you can see, there is no H here, right? Because if we don't have H or B, for example, let's say 1000 1010 B, it means that we have a binary number. So let me increase the eraser like this. Yeah. So A right now is 215. B right now is 3, and we divide them. But let me explain to you because it's not just that simple to understand that first in the beginning. Because actually in the division instruction we do two operations at the same time for A and B. If you want to find the value for A, so it should be like this: A divided by B. If you want to find the B value from that, you have to A modulus B. So let's go on a bit down. So A is 215 divided by 3. So 7, 5, So the value is the integer part, which is 71. And how to say, if you remember from the high-level languages that we solved in the Java or C, we sometimes use the modulus operator, right? Um, which gives you the remainder part. So in our case, the remainder part is 2. So A is 71 and B is 2. That's our answer. But actually, uh, I would like to represent these numbers in the hexadecimal, just to remind you how we deal with hexadecimal representation, or when we convert the decimal to hexadecimal. We have to just divide by 16, so it's 4, sorry, 64, so it's going to be 47, because we read from the right to the left. So the answer is 47 for the A. For the B is 2, because it's not exceeding the 15. If it was more than 15, so we could divide by 16, but it's less than 15. So that's why we just can type as 2. That's our answer for this task. Thank you for your attention.